with solvent washed plates, the solvent has to be compatible with the plate material. If you change plate material, you may have to change solvent. You have the issue of replenishment of solvent. You have where you have to, as you're washing away plate material, this unexposed plate material is becoming part of the solvent itself. So and some of it is evaporating away. So you're going to want to figure out how to replenish solvent, the right amount to replenish it, and you're going to want to dispose of used solution. Solvent wash plates take longer to dry, and you may require an air permit, and I don't know what restrictions or regulations you have here, but in the U.S. solvents, we have to monitor the amount of solvent that comes in and the amount of solvent we send to be recycled, and the difference we send into the air. And we're only allowed to send so much solvent into the atmosphere. With water wash plates, you need a dependable source of quality water. And I remember reading years ago that DuPont had created a plate, I think it was called Now. And I think it was specifically for the India market, because your water supply was not dependable in terms of quality. And so they needed a material that had greater latitude and the quality of water it would allow to process it. Does anybody here from DuPont know that story? DuPont Now? Does that even still exist?
It was an AQS. It was called AQS.
Yeah, I thought it was Now. No?
Now it's solid wash.
Okay. So, but anyhow, with water wash plates, you need a dependable source of quality water. My client in Nigeria would not be able to do it. The one that carries around 5-gallon drums for adding to water-based ink. But one of the benefits of water wash plates is that it has a shorter drying time than salt. Wick plates. There's no solvent or water. You use a wicking mat, heat, pressure, multiple passes. That little thing gets closer and closer with each pass in an increment as it wicks away the material. But one thing that I've observed that is different from the wick plates versus the other one is that the wicking material seems to impart a texture on the surface of the plates. And that could be good, bad, or indifferent, but it's just there. It's a reality. Plate materials, this is not so obvious, but your plate materials have to be consistent, compatible with your ink. There are some plates that you do not want to use with solvent-based ink. And there are some places you would rather avoid using with water-based inks, or with salt. So even there we have to be careful, okay? Same thing with washout solutions. So what are a few plate variables? The chemistry of the polymer, its thickness, its durometer, which is how hard it is, okay? Plates vary in hardness. The surface energy. I could have two plates, identical images, processed according to each's requirements, and those two different plates from different manufacturers will likely have different surface energies, or even within a certain series, and that can be accidental or on purpose, but it's a variable. So we can't just change plates without considering what that might do to our tonal quality. As a matter of fact, if we change plates, this is something you'll learn in the third program. If you change plates, you have to do a complete fingerprinting process, characterization process. Processing time is also varied. Equipment specifications, the chemicals you use, the shoulder angle. Now this is an interesting one here that's not so obvious. This angle is variable and controllable to some degree. But the angle of the shoulder is variable and it factors in and is very important. As a matter of fact, I think it was in 1987, I read an article of some girl, well, I want to say Michelle something, but I don't remember. And it was the impact of shoulder angle on tonal reproduction or something, and that's why I left it kind of dot, dot, dot. I'm recalling this, but I remember she did a study and as part of her college course, and she correlated this angle of the shoulder to some important property, like perhaps dot size or something like that, all else the same. Dr. Timothy Dotsick wrote a recent paper that was very interesting, very, very clever. Theoretical and empirical models of printing, analyzing shoulder angle and compression. And what they did is very clever. They made and this is an exaggeration, but you see, this is a steeper angle than this. In other words, they made a series of dots with differing angles of shoulder. And what they found was, I keep doing this, what they found was that when you had a shallow, when you had more angle like this versus like this, when you did this, in no time, as that plate was coming into contact, it required more pressure to compress it, and you had certain docking. But when you did it like this, you had required less pressure before, you know, it would take more compression before you would see anything. But it got to a certain point to where when you compress it, the dot would flip over. So somewhere, you know, they saw that on the extreme side of the angle of the dots being like this, it's undesirable. We'd really like to get as close to vertical as we can, but then we get to a certain critical point where we fail. So we back up from that, and it just so happens that at least in their trial, that was somewhere between 72 and 74 degrees. Point being that even shoulder angle is critical. So here we go, we're peeling the onion and we keep finding layer after layer of how profound all of this is, with all of the variability that we have in each of our elements. The ink, what we measure it with, this, that, and the other, blah, 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 now the plates. It was a very clever study, I thought.